Alright guys, here's your video for lesson 2.2, ratio tables and graphs. By the end of this video, I want you guys to be able to create ratios that represent the same value. So at the very top there it says Leela is making chocolate chip cookies. The recipe states she needs 3 cups of flour and 2 cups of sugar. This means the ratio of flour to sugar in the dough is 3:2 or 3:2. If she doubles the recipe, she will need to double these ingredients. She will need 6 cups of flour and 4 cups of sugar. The ratio of flour to sugar is now 6:4 or 6:4. Notice that 6/4 is equal to 3/2, so these are equivalent ratios. The amount of each ingredient changed when Leela doubled the recipe, but the ratio of flour to sugar did not change. You can make a table to show equivalent ratios. For Leela's chocolate chip cookies, a ratio table can be used to show equivalent ratios. So that's what this table represents here. So on the top part of the table, that is the number, that's the amount of flour used compared to the amount of sugar used. So this was the initial ratio. All right. So it says you can use repeated addition to find tables or find values in a ratio. So again, pause the video, okay, and make sure you guys understand how this table works. For the second part of the table, it says you can also use multiplication to find values in a ratio table. Using the simplified ratio, 3/2, multiply both values in the ratio by the same value. So 3 times what is 6? That's 3 times 2. 3 times 3, that's 9. And 3 times 4 is 12. But whatever you do to the top part of the table, you have to do to the bottom. So 2 times 2, that's 4. 2 times 3, that's 6. And 2 times 4, that's 8. So equivalent fractions are like 3/2, that's equal to 6/4, which is equal to 9/6, which is equal to 12/8. So those are all equivalent ratios. Let's take a look at the next page. In example number 1, it says Petra saves $3 for every $1 she spends. So for part A, it says complete the ratio table to show the relationship between Petra's amount saved compared to her amount spent. That's for part A. For part B, it says create a table to model this relationship. And then for part C, it says what does the point 15.5 represent in this situation? So again, what I would do is pause this video and make sure you guys read through the solutions. Okay, look at the diagrams, look at the tables, and then look at the chart there for part B when it says graphing. So make sure you guys pause the video and take a look at this example. At the bottom there, it says the graph of a ratio table gives a visual model of the ratio. The numbers in each ordered pair on the graph represent equivalent ratios with other ordered pairs in the graph. The real-world meaning of the point 15.5 on the graph represents the situation where Petra saves $15 and spends $5. In some situations, the simplified ratio is not shown in a ratio table. You may need to use division to find the simplified ratio before using multiplication to find an equivalent ratio. Let's take a look at the next page. So on example number 2 here, it says the Heinz Park Service planted 16 birch trees for every 40 oak trees. Use the ratio table to determine how many birch trees will be planted when 55 oak trees are used. Okay, so I'm going to change this up just a touch, okay, just to kind of explain and set you guys up for when you guys start doing work on the tiered worksheet. So what I like to do is I like to take my original ratio, which is 16/40, okay, 16/40, and simplify it. So what's the greatest common factor of 16 and 40? The greatest common factor of 16 and 40 is 8. So 16 divided by 8 is 2, and 40 divided by 8 is 5. So that is my simplified ratio. And then what they're doing here is they're saying, what do I have to multiply 5 by to get 55, that's 11. And whatever I do to the bottom number, I also have to do to the top number. So that's why they're multiplying 2 times 11 to get this ratio of 22 55ths. Okay, so that means 22 birch trees will be planted when 55 oak trees are used. All right, so sometimes you can use division, but like I said, what I like to do is find out what my base ratio is, right? What my smallest ratio is. Okay, moving on to the next page. Okay, so for number 1, it says create 2 ratios that are equivalent to 1/3 using multiplication. So this is where you guys get to do what you want as far as the creating 2 equivalent ratios, k to 1/3. Just choose a number, something within reason, of course. But hey, it's up to you. So I'm going to choose 5. So I'm going to multiply both the numerator and the denominator by a factor of 5, because whatever I do to the top number, I have to do to the bottom number. So 1 times 5 is 5, and 3 times 5 is 15. So therefore, 1/3 is equivalent to 5/15. Same thing on the other one. So choose another number besides 5. Let's say 7. So I'm going to multiply both the numerator and the denominator by a factor of 7. So 1 times 7 is 7, and 3 times 7 is 21. So those 2 ratios are equivalent to each other. Let's take a look at number 2 and number 3. On 2 and 3, it says complete the ratio table using repeated addition or multiplication. So for this number 2, it says they're comparing the number of mice to hamsters. So my base ratio is 1 to 4. So if you look at it, so I'm adding, so in the numerator I'm going 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. So I'm adding 1 every time. So for the number of hamsters, let's see, 4 plus 4 is 8. 4 plus 4 is 12. 12 plus 4 is 16. And 16 plus 4 is 20. So that's one way you can use repeated addition. And it's really helpful, okay, when you know what your base ratio is. For number 3, we're comparing laptops to tablets. So this is my base ratio, 5 over 2. So in this case, how did I get from 5 to 10? What do I do? Did I add? Well, if I add 5, okay, so if I go plus 5, that's 10. 10 plus 5 is 15. 15 plus 5, that's 20. And then 20 plus 5 is 25. All right, now let's see about the number of laptops. So with laptops, I'm missing some numbers here. I'm missing those 2. But if I go from 8 to 10, how did I get to that? What did I do? I added 2. Well, let's see if that works with the other numbers. So if I go, so I'm going to erase this. If I go 2 plus 2, that's 4. 4 plus 2, that's 6. 6 plus 2, that is 8. And 8 plus 2 is 10. So that's one way you can do it. Pretty straightforward, pretty simple. On number 4, it says graph the ratio table on the given coordinate plane. So we're comparing cars to bikes. So the cars are along my x-axis, and my bikes are along the y-axis. Maybe you've been introduced to that concept of axes before. I don't know. But that's what we're doing here. So let's go ahead and plot our first set of points. So if these are all 1, so 1, 2, 3, 4, and 5. And along the bikes, I'm going to go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the values there of each line. So for every one car, there's 2 bikes. So that's my first point. My next coordinate is 2, 4. So for 2 cars, I've got 4 bikes. For 3 cars, I've got 6 bikes. For 4 cars, I've got 8 bikes. And then for 5 cars, I've got 10 bikes. And there you have it. Number 5. On number 5, it says a chef's recipe uses 10 cups of flour for every 3 cups of milk. Use the ratio table to determine how many cups of milk will be used when 80 cups of flour are used. So let's see here. I'm going to use multiplication. So how did I get from 10 to 80? I multiplied 10 by 8 because I'm going up by a factor of 8. But whatever I do to one number, I have to do to the bottom number. So I'm going to multiply 3 by 8 as well. So 3 times 8 is 24. So I'm going to need 24 cups. Oops. Of milk. All right, on to the next page. All right, so here we are on the back page. So for this situation, for these problems, it says a restaurant tracked the orders of soups and sandwiches throughout one day. Use the graph to answer the following questions. Okay, so for number 6, it says the ratio of sandwiches to soup is blank, colon, blank. So when I'm looking at a chart like this, what I like to do first is I like to label my axes. So the sandwiches are along the x-axis, and my soups are along what's known as the y-axis. So sandwiches, so that's going to the right, and my soups are going up. Okay, so what I like to do in situations like this when I'm looking at these graphs is I like to choose the point that is closest to what is known as the origin on my coordinate plane. And that's what this is called. But this point is called the origin. The whole thing is a coordinate plane. Anyways, so I'm going to choose that point that I circled. So how many sandwiches does that represent? That represents 2 sandwiches. So I'm 2 spots to the right from the origin. And then I go up. Okay, and that tells me how many sandwiches there are. And then I go to the left, and that tells me how many soups there are. So the ratio is 2:1, or 2 to 1. So for number 7, it says when 8 sandwiches are sold, or had been sold, blank soups had been sold. So from the origin, I'm going to go all the way over until I get to 8 sandwiches. Okay, and then I'm going to go up, and then I look to my left, and that tells me how many soups have been sold, which is 4. All right, so when 2 soups had been sold, so now we're changing it up a little bit. So I'm going to choose the green. So when 2 soups had been sold, how many sandwiches have been sold? So from the origin, I'm going to go up this time to 2 soups, and then I'm going to go to the right until I get to sandwiches, which is right there. And then when I go down, that's 4 sandwiches. Now on number 9, it says using the same ratio, place a point on the graph to represent the relationship between sandwiches and soup when 12 sandwiches were sold. So in this case, what I'm going to do is I'm going to choose the last point that we left off at, which was this one right here. So if I know that the ratios of sandwiches to soup is 2 to 1, from that point, I can calculate how many soups were sold when 12 sandwiches were sold. So if my ratio is 2 to 1, I'm going to go 2 to the right. Okay, so 2 sandwiches for every 1 soup. So where do I end up at? So when I sell 12 sandwiches, I end up at, I go all the way to the left, 6 soups. So when I rewrite this as a point, here's how I would write this. So for 12 sandwiches that were sold, there were 6 soups that were sold. And those are the coordinates for my point. All right. So then on number 10, it says, if the pattern continues tomorrow, how many soups will be sold if this restaurant sells 80 sandwiches? So what I like to do, like I said, since I have a base ratio, I'm going to write that down. So for every 2 2 sandwiches that are sold. Okay, there is 1 soup sold. Okay, so if I'm going to write an equivalent ratio, okay, I have to ask myself, what am I going to multiply 2 by to get an answer of 80? Because this is going on to the next day, right? So 2 times what is 80? Well, that would be 40. And then whatever I do to the top number, I have to do to the bottom number to make sure they're equivalent. So then 1 times 40 is 40. So my answer is 40 soups. So if 80 sandwiches are sold the next day, then 40 soups would be sold, okay, as well. All right, that's all I got. If you need help, make sure you ask. Mr. Burns, out.